Assalamualaikum and hi to those watching this video. First of all, I want to introduce my group member first. Alif Daniel, Hakim, Wan Mustaqim and Alif Aiman from group CDCS 143-2B. My name is Muhammad Hakim Muhammad Nasir. Will explain to you all about differentiation. So let's be started. What is differentiation? In calculus, differentiation is apart from integration. Differentiation is a method of finding the derivative of a function. Differentiation is a process in math where we find the instantaneous rate of change in function based on one of its variables. Application of differentiation. Application of differentiation such as related rates, analysis function, decrease, increase and concavity, Rolle's theorem and the mean value theorem, maximum and minimum problems, analysis of function, relative extrema, first and second derivative. Example of differentiation. Here the sum of the example differentiation that we get, such as to get temperature variation and to determine the speed or distance covered, such as miles per hour, kilometer per hour and etc.
Hi, I'm Muhammad Alif Aiman. We'll tell a little bit to you about differentiation. Differentiation is a process of finding the derivative or rate of change of a function. In contrast to the abstract nature of the theory behind it, the practical technique of differentiation can be carried out by purely algebraic manipulation using three basic derivatives, four rules of operation, and knowledge of how to manipulate function. Next, I'm going to tell you about related rate. Related rate problems typically involve finding the rate at which one variable changes by relating the variable to one or more variables whose rates are known. Procedure to do the related rates calculation. First, find equation that relates the two quantities. Then you can use the chain rule or implicit method. Related rates and problems involving related rates take advantage of quantities that are related to each other. Related rates help us to determine how fast or how slow a certain quantity is changing using the rate of change of the second quantity.
Solving related rates of change problems also has extensive applications in finance, physics, travel, and transportation. Framing problems in terms of related rates allows us to write a rate of change in terms of another, typically easier to compute rate of change. Example 1. As time progresses, the water level within the cylinder increases. This also means that the volume of the water inside will be varying with respect to time. We can use related rates here if we want to observe the rates of change of the water levels, height and volume with respect to time.
Assalamualaikum warahmatullahi wabarakatuh. My name is Tuan Mustaqim bin Tuan Ismail and I will talk about the problem that have in our task, or it's like problem equation. For the first of all, I will talk about the problem statement that have in our question. The statement is the diagram show a plant XY of length 20 meter leaning on a wall of building. The end X is h meter from the level of the ground and the other end Y is W meter from the foot of the wall set. The question is find A. The rate of change of n x of the plant in ny slide away from the foot of the wall at rate of 6 ms the power of -1 when w equal to 60 meter. Question B is to find the rate of change of ny of the plant if ns slide down at a rate of 4 ms the power of -1 when h equal to 12 meter. For the solution for the question is like in the next page. For the question A, for the first, we should search what the question 1 is like. In the question A, the rate of change of nx, that is the key that what the question 1, and the clue that have in the question we should search in the next step is like the differentiation of w that right in the question is 6. So we should write dw over dt is equal to 6, and the next we should write or make the equation that write like the dh over dt is equal to dh over dw times dw over dt. How we want to get the dh over dw is like in the step 3. For the first, we should write h is equal to 20 the power of 2 minus w the power of 2 and power of 1 over 2 or square root. This is the theorem Pythagoras. So in the last we can get the dh over dw is negative w over 20 the power of 2 minus w over the power of 2 and square root. So in the next we should replace the value of dh over dw and dw over dt. When we replace it, in the next we get negative 6w over 20 the power of 2 negative w the power of 2 the power of 1 over 2, and the next we should enter the value of w is like in the question we should replace the value of w is 60, and in the next we get the answer is negative 96 over 12, and in the last we get the answer for the question for this question is negative 8 ms the power of -1. For the question B, we should do the same step. For this question we should search the rate of change of ny, or is a differentiation for the w, or is also we can write dw over dt. So in the step 2 we should search the clue, and the clue for the question B is the differentiation of h is equal to -4. For this question, if we see at the problem statement, he write just 4 ms the power of -1. Why we should write the -4 is because in the problem statement it write x the part of if an x slide down at a rate of 4 ms the power of -1. In this case, the length of the x is decreased, so we should write the value of 4 is negative. So in the next we should write the dw over dt is equal to dw over dh times dh over dt. It's also said we should how we want to search the dw over dh. for the first, we should write in step 3, W is equal to 20 the power of 2 minus h the power of 2 power of 1 over 2, and in the next we get the value of dh over dh of dw over dh is equal to negative h over 20 the power of 2 negative h the power of 2 power of 1 over 2. For the next, we should replace the value of dw over dh and dh over dt. In the next, when we get the value of dw per dt is 4h per 20 the power of 2 minus h the power of 2 square root, and we should in the next we should replace the value of h. So in the next we can get the answer. It's like in the solution we can get 48 over 16, and in the last the answer for the question is 3 ms the power of negative 1. For the next, I will talk about our conclusion in our task page. The conclusion, for the first conclusion, the application of the differentiation is used to compute the rate of change. It's like we can accurately count the difference in the change happen. For the conclusion 2, the solution used to find the value of relate rate are success. And the last, we can use this way to answer another problem that relate in our daily life. This is all for me. Thank you, and I hope we can meet another time. Thank you. Okay.